stop you from asking any questions that you may have. Because you are muted, you can definitely talk to me through the Zoom functionality and chat, as well as through the question and answer section. Okay, so this training is intended for training purposes only. I do want to reference that because if there's any products here that we're going to be talking about, please refer to DaytonSuperior.com. You can find all technical information, application information, all of that out there on DaytonSuperior.com. And it's real important that you look there before using any of our products. As a reminder, we record each and every one of these training Tuesdays as well, and we put them out there for your convenience if you want to forward it along to someone who might want to watch it later, or if you want to rewatch it to learn or to get some idea on it. But these training Tuesdays are short and sweet, to the point, to get you hopefully quick, efficient. But if there's something that you need more of, please contact Chuck or myself, both of us, through training@DaytonSuperior.com. And leading into that, who the heck is Dayton Superior? One of the things that we like to say is we're not about splicing like we're just about splicing like we're going to talk about today, but we've got forming, we've got chemicals, whether it's for repair or retrofit. We've got your precast, your tilt up. We've got the whole gamut of concrete construction products. And I'm excited because Sam Conley is one of my besties, and he's going to talk to us about threaded rebar splicing. So I'm going to tell you a little bit about Sam. He joined us here at Dayton Superior as a splicing products training representative in 2021. He is still, I think, hanging out in the East, aren't you, Sam?
Yes, I am. I live in New Hampshire.
That's right. I always want to ask you because we've got some other ones all over the place. So he's one of my favorites, and he provides that sales support with technical and product training for his customers and me sometimes when I need it. And he also does specifications for the State Department of Transportation for the splicing stuff. He has been around for 24 years with his experience in the construction industry, focusing on the rebar sales, fabrication, and job site installations. So he is your go-to man for this. So Chuck and I are all ears. I hope you guys on there are as well. So take it away, my friend.
Thanks, Heidi. Thanks, everyone, for joining us for our intro to rebar splicing. We're going to be talking about splicing techniques, industry standards, the product offering from Dayton Superior, and touching on why we really need mechanical splicing products and lap splicing and the differences between the two. So you may even ask, what is lap splicing? Why do we need mechanical connectors? That's a good question. Rebar fabricators secure straight lengths of rebar in various lengths, anywhere from 30, 40 to 60 feet. They cut and bend that on a per job basis. Every job is a little bit different. Those pieces all have to be cut and bent and sent to the job site and assembled. And concrete is a great building medium, but by itself, it's insufficient. It needs the strength of steel to complete the system and deliver the final package. And that's where rebar comes in. So all those pieces of fabricated rebar have to be put together, and through any concrete segment, each length of rebar, each piece, they need to act as one. So you can't transport, 100-foot piece of rebar. So you have to ship them in sections. So it's kind of like a rebar jigsaw puzzle that is put together at the job site. So those pieces of bar need to be connected. And the manner in which it's done is either through a traditional lap splice, which you can see here on the screen, or through mechanical couplers, which we're going to be looking at. So lap splicing involves putting the bars side by side and tying them together with tie wire to make sure that they stay in position during the concrete placement. Tie wire doesn't have any structural integrity. It just keeps the bar in place. Lap splices, one of the major differences between that and mechanical splicing is that lap splices need the strength of the concrete in order to function properly. So it's a system that works hand in hand, both pieces together. You can use lap splices for sizes 4 through 11, Numbers 14 and 18 are not able to be lap spliced. And for those, you have to use a mechanical coupler. So here's an example of a repair situation where it's a good illustration of lap splicing and how that concrete has to be incorporated in order for it to work. So you can see that in this repair situation, the concrete's been removed. Lap splice, as it sits there right now, doesn't provide the full level of strength. It's got to be surrounded by the replacement concrete, and the two systems work together to deliver the final package. One of the challenges with lap splicing is because it does require additional steel, that it can create congestion in the structure. And congestion inhibits the flow of concrete. It can prevent the concrete from being completely consolidated. There could be voids that are not intended. So it just takes up more room. The illustration on the left is an illustration of traditional lap splices and how it fills up that concrete segment. If some of those lap splices are replaced with mechanical couplers, as shown in the illustration on the right-hand side, it opens up that assembly. It's less congestion, and the concrete is able to incorporate itself completely around those concrete members. Some more illustrations. The illustrations on the right and left are good examples of congestion. Because concrete is such a great building medium, designers are asking it to do more and more, perform at a higher and higher level, and therefore requiring more and more steel. So there are various ways of getting around that congestion that's created by lap splices with either headed bars or mechanical couplers. The illustration in the center, once again, is an illustration of how it's a dramatic illustration of how rebar cannot function without the concrete. You can see during some event, the concrete has spalled away from the steel, and the steel has deformed and lost its structural integrity. Lap splices are still very common. They're used in a lot of situations, and sometimes it is the most appropriate. I often get asked about when is the best time to use a mechanical splice, and the answer to that is really kind of depends. It depends upon a number of factors: the bar size, the constructability of the structure, the construction practices of the forming concrete, or the forming contractor and the concrete placer. So there are a lot of different variables, and many times the answer is that mechanical splicing is the best choice for productivity and for cost considerations. So a mechanical splice brings together the two pieces of rebar, either with a mechanical sleeve or with a tapered thread. Those threads could be parallel or tapered. And another less common use or application is a grout-filled mechanical coupler, which we will be taking a look at. One of the important features of mechanical couplers over lap splicing is that the mechanical coupler itself provides the full strength of the bar. It's not dependent upon the concrete. And when we do testing in our labs, it's all open air. There's no concrete involved. We just assemble the bars with the couplers and test them in that situation. So they do have that advantage over the lap splice as well. And once again, the intention is to allow the multiple pieces of bar to act as one continuous length inside the concrete structure. So the various types of mechanical couplers that are available are the shear bolt coupler, which is illustrated here. It's a steel tube with serrated edges on the bottom and bolts at the top that, when they're tightened down, penetrate into the rebar, and at a specific torque, the proper torque level, the heads will shear off. So there's no guesswork. There's no need for calibrated tools. The heads shear off at the proper torque. It's very easy to install. Other types of mechanical couplers that we're going to be looking at are taper thread, parallel thread, and, as I mentioned before, the grout-filled pieces as well. So mechanical splicing, we're going to look at some of those techniques. They're precise and reliable. They're tried and true. They can oftentimes be a cost-effective application over the lap splicing for both material costs as well as installation and productivity. They can save time. They are stronger, as I said, than the lap splice because it's not dependent upon the concrete. So the strength of lap splices have traditionally been described as a type 1 or a type 2. This is a definition that's found in the ACI 318 code that covers concrete construction. A type 1 splice requires that the mechanical coupler meet at least 125% of the yield strength of the bar. Now, the yield strength of the bar is where the bar stretches and cannot return to its original shape. Forces below that, you can actually pull the rebar, it'll stretch, and then it'll return to its original configuration. That yield point is where you stretch it to the point where it does not go back to the original shape. So the type 1 splice has to meet 125% of that force. A type 2 splice, which is the stronger of the two, has to do the same thing, 125% of the yield strength of the bar. But in addition to that, it must meet 100% of the tensile strength of the bar. So in essence, when we test them, the bars break before the coupler does because they exceed 100% of the tensile strength of the bar. We do extensive in-house and third-party testing of all of our rebar splicing products, and then we submit those products and test reports to IAPMO. IAPMO is a service that will evaluate our products and all of the testing results. They then produce a report that looks like this. This is their evaluation report. Number 319 covers our mechanical couplers. So in essence, it's an independent agency that verifies that our products perform as we say they are going to. So these reports are available on our website and from any of your technical or sales representatives. We're going to take a look at some of the very specific types of mechanical couplers that are offered by Dayton Superior, both the shear bolt and the threaded. This is a straight threaded mechanical coupler. It's our D50 DBR product. And that illustration is very effective because it shows how the thread is cut into the rebar and actually reduces the cross-sectional area of the bar itself. So this mechanical coupler is a type 1 coupler. It can't function as a type 2 coupler. But type 1 is also very common, used in a lot of instances. We produce this in sizes 4 through 11 with various corrosion protections, such as epoxy and galvanized. Our next threaded product offering is our DBDI product. And this product is forged out of the rebar. So the pieces on the left, both the epoxy and the plane, are form-saving couplers. They have the coupler and the flange formed completely out of a piece of rebar. These are hot forged in our shop they're heated up, and then through a multi-step stamping process, the coupler, the flange are formed, the hole is punched into it, and then in a separate function, we thread the bar or thread the coupler. Once again, the DBDI is a straight thread offered in UN and UNC varieties of threads. The threaded bar is also forged. The end is upset, it's enlarged prior to the threads being cut on it. So these threads are actually larger than the cross section of the bar itself. So this functions as a type 2 coupler. Once again, that means it meets the 125% of yield strength and 100% of the tensile strength of the bar. And these are included in our IAPMO approval report. They're easy to install. It is a form saver type coupler. They are hand assembled and require only 5 foot-pounds of torque to fully develop the full strength of the splice. So no need for any calibrated torque wrenches to be applied in order to get the proper installation. So these are available in sizes 4 through 11. We can customize them in just about any configuration. They can be straight, they can be bent with a 180-degree hook, 45-degree, 90-degree. We can also produce them with couplers at each end of the bar as well. So it's highly customizable. And again, these are offered in various corrosion protection. We offer it in epoxy coated, and we could do them in stainless steel. And we also offer them in hot dip galvanized as well. And I mentioned that it is a form saver coupler, and this is a good illustration of that. Wherever there are segmental pours of concrete, there will be a joint of some sort. And a concrete contractor has a couple of choices. At that joint, the rebar needs to run through the joint from one segment of concrete into the other. So one solution during placement is that you could drill a hole through the formwork. Well, that's a little problematic and destructive to the formwork. An alternative to that is the form saver can be used. So you can see in the top 3 illustrations where the coupler is attached to the form, either screwed or nailed on. The concrete is placed in that segment. And then once that is cured and is stripped, you can see in the bottom 3 photographs where once the formwork is stripped off, in the left-hand lower corner is a good illustration of how the flange and the coupler is exposed after the formwork is stripped, and then the threaded bar can be threaded into that. And in the final section, the final photograph there on the bottom right, you can see the series of bars that have been installed, and then that segment of concrete can be placed at that point. So time saving and material savings, no need for the contractor to put holes in the formwork. In the forging products, we also offer end anchors. End anchors are a great way to address the congestion that we looked at earlier in the earlier slides. They are heads that are hot forged onto the bars in various configurations that are shown here. So the end anchor replaces hooks. It can replace 180-degree hooks and 90-degree hooks. And once again, it's a great time saver, and it can also save some material costs as well. A couple of illustrations here that show how end anchors are used in this section. On the left-hand side, traditional with hooks. On the right-hand side shows the assembly with end anchors used. These are very versatile. We provide them in sizes 4 through 11 in the forged version. 2 more illustrations that show good vertical and horizontal applications of this as well. So moving on to taper lock. Taper lock is Dayton Superior's proprietary tapered thread coupler system. And you may ask, why do we use a taper thread instead of a traditional straight thread? Taper thread has become the preferred method of coupling in the field due to the fact that it goes together quickly. It's easy to assemble. The iron workers don't need to worry about cross-threading as is common with straight threaded products. The taper thread goes together very easily. The photograph on the left-hand side there is one of our check gauges that is used during our quality control process, but it's a great a view of what the inside of the taper lock coupler looks like. You can see the penetration into the coupler and the thread engagement as well. So this is a type 2 coupler. It's available in grade 75, 60, 75, 80, and 100. Our standard couplers are good through number 60 through 80, and then a separate product is used for the grade 100 offering. These are available in sizes 4 through 18, as well as size 12 for the markets that have size 12 rebar also. We're going to be looking at our threading machines that we place with fabricators at no charge. And they do the bar threading in their shop. We provide the couplers, and the fabricators can use our machines to thread the bars. And once again, this is a very cost-effective alternative. It goes together easily, and it also only requires 5 foot-pounds of torque to develop the full strength of that type 2 connection. So no special tools are needed to do the assembly. Here's a great photograph, a couple of good photographs of our taper thread machine. It'll do, as I mentioned, up to size 18 and grade 100. It's fast, efficient, it's safe, self-contained, uses a water-based cutting fluid, and it's a top performer. So we'll take a look at all of the product family of taper lock. This is the standard coupler, which is used to connect 2 pieces of rebar at the same time. And with all threaded couplers, with the exception of one, which we'll take a look at, but the standard threaded couplers require that both bars be able to turn. So or at least one of the bars, because you can thread the coupler onto a stationary bar, and then the second bar that is threaded into it has to be rotatable. If that's not possible, we'll look at a solution for that here in just a moment. We also offer the D320 transitional coupler. This is used to connect bars of different sizes together. We can accommodate just about any size combination with the transitional coupler. Very often used in vertical applications, in mid-rise and high-rise situations where the column bars have smaller diameters as the structure moves up in floors. Now, the D330 positional coupler provides a couple of functions. The photograph on the right-hand side shows a great application in a vertical member, a column. The transitional coupler, because it is a multi-piece coupler, has a threaded barrel in the center there that allows for adjustment. In this case, it would be vertical adjustment. Many times during the detailing process, the final lift of bars in a multi-story building isn't always known at the time that the project is detailed. Once the columns are installed, the contractor is going to know what that final elevation is. You can use transition couplers for the last lift, and those couplers will allow for a couple of inches in adjustment vertically. So it's a good solution for that. As I mentioned before, the bars need to be rotatable to put traditional couplers, threaded couplers together. If the second bar that's going into the coupler has a hook on it, you may not be able to turn it and rotate it into the coupler. So that bar, if that's the case, that bar can be put in place and a position coupler can be used so that you essentially thread one side of the coupler out onto the bar itself. So you're rotating the one section of the coupler as opposed to the bar itself. And the drawing there at the bottom is a good illustration that shows how each end of that coupler has a taper thread to receive the bar, and then the center portion is the threaded barrel that allows for the adjustment. The D340 is essentially a standard coupler with a flange on it. And again, this functions as a form saver, exactly like we described before. So this is a very, very popular offering that is a good solution for those segmental pores. We also offer the D350 and D351 taper lock end anchor. This end anchor, again, is a headed bar. It is designed to eliminate hooks to relieve congestion. So there are a couple of photographs that are good illustrations of how that is done. Often there are situations that combine cast-in-place concrete with structural steel. and the bars need to be attached to the structural steel. The D360 taper lock weldable coupler is the solution for that instance. So it is a half coupler that has a chamfered side that is welded to the structural steel. You can see here how that's done. These are becoming more and more common, pretty popular in a pretty popular solution for a situation where the bars need to be combined with structural steel. So now we're going to move on to look at one of our more unique couplers. This is the sleeve lock grout sleeve coupler. The sleeve lock is essentially a cast iron uh, tube, a sleeve that the bars are inserted into, and then after insulation, the concrete is poured into, or not concrete, rather, it's grout that is pumped into the cylinder, surrounds the bars, and creates the connection. So you can see the various components on the upper right. There's a nice cutaway of how that coupler works. The center section is the center section is oops, got to go back. Sorry about that. So the grout fills the center section of the bars. This is a good illustration to have how they are installed. Very common in precast construction. There's one application that's typical in cast in place that I'll go over here in a second, but the bars are installed in a precast element. You can see half of the bar, or the couplers are installed. Half the bars are placed into the coupler. You can see bar supports here, these high chairs supporting the bars. This is prior to the pour of the concrete. Once those are installed, the concrete is placed. Here's another good illustration of what it looks like during the installation. The concrete then is shown on the right-hand side. Once it's placed, the grout ports are exposed on top of the concrete segment. They can be placed, the pieces can be placed together, and then the grout is pumped in through the ports to fill up the coupler with the grout to develop the full strength. Our newest offering is the D390 taper lock grout sleeve, which combines the traditional taper lock taper threaded coupler with the grout sleeve. So on one end, you have the traditional grout sleeve where the bar is placed, and then the opposite end is a threaded section that the taper lock bar can be threaded into. So this once again develops the ultimate strength of the rebar, exceeds 100% of the tensile strength, and can be used in the various applications that are shown here. And it's becoming more and more popular all the time as well. Here's a breakdown of some of the components that come with it. The seal plug, we have a form plug that can be used as a form saver at the precasters facility. We have a proprietary high strength grout that is a high early grout that is pumped into the coupler itself. Here's an illustration of how it can be commonly used in precast or in cast and place situations wherever there is a pour strip. A pour strip is generally designed to allow for various segments to cure during, before final placement of the last piece of concrete. So a pour strip is left open, and then there's a need to remobilize, come back and pour that. The bars, the theory is that as the various segments cure, the bars have the opportunity to move a little bit during the curing process. The use of the D390 grout sleeve eliminates the need for a pour strip. So that pour strip can be placed with a simple joint. So the bars are placed into the D390. The curing process takes place, but the grout is not placed into the coupler until the final cure strength has been achieved, maybe 28 days after the placement of the slab. So there's no need to come back and remobilize and pour concrete in a pour strip. You can simply fill the D390 with grout, and seal up the joint. It's a cost-effective, much more efficient way of placement as opposed to a pour strip. An illustration of how these couplers can also be used in vertical and horizontal applications as well. So here's a list of some of the various agencies that oversee the design of concrete and the use of mechanical couplers. Dayton Superior is an active member of the Concrete Reinforcing Steel Institute, CRSI, as well as ACI and some of the other agencies that are listed here as well. So we're very active in the industry itself. We have our own internal testing lab where we test all of our products on a regular basis. So just a quick look at some of the applications, parking garages, stadiums, very common in high rises. These are all places where mechanical splicing is definitely a good option. Water treatment plants, wastewater treatment plants, and of course bridges in both the substructures and the decks. We do offer, we make available PDF order forms, such as that one, that can be used. They're editable PDF forms that could be filled out and then sent to our customer service people for quoting.
Sorry, Sam, I changed it on you, taking it
Yeah,
back.
I see you're interfering there, Heidi.
Good way to.
But I think that's good timing because that's all I
My turn.
have. I'll turn it back over to you.
I wasn't going to let you take the heat for that one. So yeah. Guys, I asked you already, but if you do have questions, go ahead and put them into the chat or the Q&A section, and we'll get those taken care of for you. But I do want to show you more of the resources that you briefly saw because I took it away from Sam for a second. We do have DaytonSuperior.com. We always talk about it, but it really is a great place to get the technical data sheets, the handbooks, specifically too, I don't know if I have an image here, but the contact information. So Sam is, like I said, a technical sales representative for the East, but we also have them for the West. We have them for different areas. We have them for precast and tilt tap. We have your regular dealer sales manager. We have the Chuck and Heidi's, and all the phone numbers are out there by state. So you just find where you live on that state, and the contact information of who you need to call is right there. So I'm not seeing any questions. So there was a lot to take in during this time frame. We actually have specific training Tuesdays just on like grout sleeve and sleeve lock. And we didn't talk about bar lock, but we have that out there as well. I started the conversation with, if you need more training, then we are here for you. There's a QR code right there that you can scan right now and put in information if you need Chuck and I's assistance, or even if you want me to send Mr. Sam out and he can do longer conversations, more customized to what you needed for your company. So I don't see any questions. We are 4 minutes over, so I'm going to stop it. But if you do have questions, please feel free to email them at training@daytonsuperior.com or through that QR code. I know I just said to request, but it all comes to us so we can figure it out for you. And I will get the recording out there in a couple hours and placed on the website. I saw somebody had a question for it. I'll send you the email with the direct link for the person who asked that question. And next week, we're going to be talking about pre-stress. So get signed up for that. And I'm excited. Thanks, Sam. I appreciate you coming and hanging with us this week.
Glad to be here. Thanks, everybody, for joining us.
Yeah. Chuck, say bye.
Bye.
Yeah.
Thanks, everybody.
Bye now, everyone.